Thank you. Okay. I also need to do one more thing. Okay. All right. So then calculate the average speed of Skydiver in the first 4 seconds. So we want to find average speed in the first 4 seconds. That is here. This is a triangle, 40. So first we find the distance. So half times 4 times 40. That would be, I think, 2 and 40, 80 meters. And then what you do? You do average speed equals to 80 divided by 4 seconds. That has to be 20 meters per second. Please do not forget about units. Then define the moment of a force. So moment is basically force multiplied by perpendicular distance about a pivot. Now, so this is center of mass. There's a pivot, as you can see. And what does it want? It says that calculate the weight of the rod. Okay, the mass is this. So W equals to M times G. So it's 0.80 newtons. Then moment. For moment, you need to take the force and the perpendicular distance, which is this. So 0.8 times 0.25. All right, I need the calculator. 0.8 times 0.25. This is 0.2. 0.2 Newton and meters. Now, the moment F, yes.
Why did it take 0.80? That's the weight, right? We need force.
Yes, moment of weight about pivot. Weight is force.
Okay.
Okay, the moment F about the pivot. So now we want to find F. F's moment is 90 degree is this. So this is the perpendicular distance. This will turn, if you look at it, this is the pivot. So this will try to turn it this way, which is anti-clockwise. And this will try to turn it this way, this is clockwise. So we have to use principal moments now. Oh, we have to find the moment about F. Well, it would be the same as this because according to principle of moments, moment is the same. It's balanced, anti-clockwise, clockwise. Now we want to find the force. So moment is the same and the force times perpendicular distance. This is this and the perpendicular distance 0.75. Clever. So 0.2, 0.75. So it's 0.27 newtons. Okay, like that.
Right?
In a yes.
For the third part, we won't subtract 0.75 minus 0.25 for the distance.
No, why? It is a separate distance. That is separate. You have to look where is the force and what is the perpendicular 90-degree distance to it till the pivot. Like this was the force, it's 90 degree with this. It has nothing to do with the other ones. The angle between rod and the vertical is increased. Stein explains the force needed to hold the stationary rod must be increased, decreased to stay the same. It's saying if we increase the angle, like this angle, how can we increase the angle? Point. If I put it, if I move it up like this, the angle would be even greater. What do you think so? Anna? So it says what will happen to this force? Do we need to increase it? Do we need to reduce it or what? Of course you need to increase it because now the perpendicular distance becomes smaller like this. So to get the same moment, you need greater perpendicular, force. So how am I going to write it? It will decrease the perpendicular distance. So to get the same moment, F needs to be larger. All right. Because if you don't know, the moment is force times the perpendicular distance. So if you divide distance in, they're inversely proportional. Smaller distance means greater force required for the same amount of moment. So you got to remember that. All right, now going to the next one. The kinetic energy of air passing wind turbine is every minute is this. The electrical output is this. Calculate the efficiency. So first we will talk about the input. Input is the power, energy of the wind divided by the time. So I'm going to check how much input is there. 720,000 divided by 60. I divide by 60 because I want to convert minute into seconds. So I got what? And then I got output. Output is power equals to voltage times current. So 9 times 240. That is 2160. Now efficiency is equal to output over input times 100%. So let's do it. So this is 18%. We've already given percentage, we don't need to write it like that. This was pretty simple. Now let's go to this one. State the name of this type of thermometer. This is a thermocouple.
Sir, can you do it again?
Where? This one?
Yes, energy.
Yes. Okay.
Okay, sir.
Now going. Thermocouple. With the setup in figure 4.2, the voltmeter reading is 1.7 millivolt. Calculate the temperature of liquid X measured by a thermometer. Temperature of liquid X. Well, okay, not bad. Temperature of liquid X we need to find. And we have the voltmeter reading here. And initially, if you see at 0, the voltmeter reading was this. Now, the difference of temperature here is 100 degrees, right? So we can say for 100 degree of the temperature, it shows 5.4 millivolts, right? So 100 degree change is 1.7 millivolts. Then how much change would it show for 5.4? How much change would it show for 1.7? Like this. So we have to make a sort of ratio, right? So we can cross multiply. So X will be equal to 100, 5.4 millivolts, right? Now 100 times 1.7 divided by 5.4. So this is around 31.5. So this is 31.5 degrees Celsius change. Now change means final minus initial. This is what changes, right? So it was initially 20 and liquid exits something. So 31.5 final temperature minus 20. So we add it. So it will be 51.5 degrees Celsius, like that. So never ever forget that this is change we are finding, not the actual temperature. So you have to add it to find actual temperature, right?
Okay.
Now, yes.
If I write 31.5, will I get at least 1 mark?
Maybe, yeah, maybe. So you have, but why won't you? Why do you aim for 1 mark when you can get 2 by
I'm saying
just
that at least.
okay? Now suggest an application for which type of more suitable in liquid and glass. Suggest an application for which this type of thermometer is more suitable than liquid and glass. Anything that requires, you know, high temperatures or rapid temperatures.
Sir, can you say measuring the temperature of lava?
Temperature of lava? Okay.
Yes.
But I don't think so it's suitable for that. Because lava has metal melted, it's very hot. This doesn't work in lava. Okay. Other thermometers can work, so don't try that, please. Rapidly changing temperature or involving higher or lower, you know, something like that. Okay. Define specific latent heat. So for this is a sort of a definition that needs to be 100% learned, right? I'm saying. So you first write thermal energy required per unit mass. So that gives you 1 mark. And if you do not write this, even if you write the next one, it's wrong. To completely change state. Now, because it is not fusion vaporization, so we can't write with liquid or solid to or liquid to gas, whatever. Now it says explain melting of solid in terms of molecules and energy. So this basically means that work is done by thermal energy to, this is number 1, and for second mark you should write to break the bonds of molecules. You can also say to overcome intermolecular forces. You could also write that, okay? Now they have given you 3,800 gram. There is a liquid, which is, I think it is boiling, right? This is what is the specific latent heat vaporization. Fine. So it says heater supplies this and the mass reading on the shown decreases from this to this. So the change in mass would be 3,800 minus 2,300. This will be 1,500 grams, right? Now it's up to you whether you want to change it or whether you don't want to change it. It's fine. If I were you, I would write it as 1.5 kg. And then I would use Q equals to LV times M. LV is the latent heat of vaporization. The energy was 1.26, mega is 10 raised to 6. This is LV, this is 1.5. So what you do? You divide it by 1.5. This is 8.4 times 10 raised to power 1, 2, 3, 4, 5. 5 joules per kg. The units must be correct. If you haven't changed it into kg, you can take it in grams, but then the answer will be joules per gram. So you have to be careful there, right? Write units up. Yes.
He didn't say that you have to change the units. Like in the
No. If you have divided by 1500, then your units will be joules per gram, like this. You should write it. You should write the correct units. Okay.
I've done mj by g grams.
Mj by G is also correct. That's fine.
Okay.
Okay. Now, state and explain precaution involved in accuracy of specific heat calculated. One of the precaution is that some heat will be lost into the surroundings, right? This is one of the biggest issue because heat is also going to go out, right? It's not just going to go into water. So what we do? Insulate the beaker with lagging. Lagging is material like woolen material, something like that. Okay. Then in this one, it says draw a label line to show the amplitude. So first of all, if I were you, I would find the middle of this wave. The middle of this wave seems to me is this the middle? I don't think so, right? This is, no. I think this is the middle. Yeah, okay. So I found the middle of the wave. Then what I'm going to do is I will use my ruler to do that, okay? The amplitude will be, you can write A, or you can write this way. It's fine, whatever, wherever. And wavelength would be from one trough to another trough. So that is also wavelength. Or a crest to crest, that is also wavelength. Or from this whole section, you can start from here till here. This would also be the wavelength, right? Now label a trough with T. So troughs are this, so I'm going to use T. Then it says a person vibrates one of the string vertically to produce wave. He makes 15 oscillations 60 seconds. Show that the speed. Now frequency is 15 in 60 seconds, right? So let's find the frequency first. 15 divided by 60. Frequency will be 0.25 hertz. Now what you're going to do? V is equal to F lambda. Speed is 2. Frequency 0.25 lambda. So 2 divided by 0.25 is 8. 8 centimeter would be lambda. Yay, easy. All right, now. Oh, it says show that the wave is 2, not, oh, sorry. I did it wrong. So this is this. Now, what you got to do is, now basically there's an issue here, okay. The point is that you need to have a ruler. It's a full size image, and you need a ruler to measure this. You need to ruler measure. And I believe that when you measure this, this is going to come as 8 centimeter because I worked it out and then it was 8 centimeter, right? So please measure using ruler because this is actual size. And then you use V is equal to F lambda, 0.25, and then 8. This would give you 2 centimeter per second. Sure, like that. So I don't have the ruler, so I can't do it. Then state the difference between transverse waves and longitudinal waves. Use your idea to direction. Transverse wave oscillate perpendicular to energy transfer, right? And longitudinal waves oscillate parallel to energy transfer. So gotta remember that. The optical fiber is made of glass that has a refractive index of 1.4. No light refracts from fiber P to Q. State the name of process occurring. That's total internal reflection because it is reflecting inside. Calculate the minimum value of angle I to be there, no refraction. That has to be critical angle. So sine C equals to 1 upon 1.4. That is the value. So C will be sine of inverse 1 upon 1.4. So how do you use the calculator for it? You press shift and sine. Make sure your calculator is in degree mode. And then you write 1 divided by 1.4. That's 45.6. 45.6. So 45.6 degrees should be the angle. Okay. So do remember that. Now it says state and explain the use of optical fibers in medicine. Now whenever this is this comes, please remember endoscopy. So what you do, right? Optical fiber is inserted into patient body through an opening, okay, like mouth. And then what you do? Light passes in the fiber to the member being studied, examined, treated, whatever you want to write. Okay? All right. And reflected back to the doctor, examiner eyes. Okay, like that. And for the third mark, you say that a camera or high frequency light is sent to make sure the image is clear. So this is the 3 points you should write. Then state what is, yes.
For the above question, like is second point. I don't get that.
So critical angle is the, why is it called critical angle? Because if the angle of incidence, right? If the angle of incidence, this angle, is less than critical angle, it will go out. Okay. Do you understand?
Yes.
And if it is greater than critical angle, it will jump in. So it's asking what is the minimum value for I. If you go below this angle, it will just go out. Don't you think so?
Okay, get it.
Right. Okay, then and the ray of light shown monochromatic. Monochromatic means single, chroma means wavelengths of light from laser. State what is meant by monochromatic light using one of the monochromatic light. State what is meant by use one of the following quantities in your answer. Right. Wow. Clever, right? Single frequency light. That should be the answer. Single frequency light. So we used it, and one for this and one for light. Then state and explain why electrical socket plugs used outside the garden need to be different from those that use safety. One of the reasons is that garden get DU. So DU is not written like this. My God, DU is written like this. So it may be damped. Right? So damping, all right. So, and for second mark, water can conduct electricity. So sockets need to be waterproof. It's very important. Now, state and explain why fusion circuit breaker installed in electrical circuit basically connected to main supply. The reason why circuit breaker or fuses are connected to main supply is that in case large current flows, the fuse or circuit breaker may cut off the supply, right? And this is one mark. The second mark is to prevent damage to electrical appliances. You can also write to prevent fire or electric shock or anything like that. Large current causes heat, by the way, if you don't know. Now, then here, draw an arrow in each of the three components. So if this is A, it means this is north, field is going on this south. So here the arrow is going to be, the field goes like this, right? So it means the arrow here will be like this. Here it will be like this, towards the south, here like this. Always going towards the south. Okay, that's good. And then label the magnetic poles. We have done it. Oh, we have done it already. And describe one method, demagnetizing bar magnet. So you can, you can write any method that you like. You could say place. My perfect answer would be place magnet bar in solenoid connected to alternating current, alternating potential difference. Then slowly pull it out. So you have to do it. Otherwise, you can heat it because the vibrations on high temperature would go. You can also hammer repeatedly. That would cause disturbance or vibration that would do that too. Demagnetize. So it's up to you. Then draw the magnetic field, show the clearly. So whenever there is single wire going, you have to use right hand grip rule, by the way. So your thumb is pointed towards the screen right now, and your fingers will curl like this. For me, my right hand fingers are curling clockwise. Now, whenever these come, you have to make sure that there should be circles, at least 3 drawn. And every time you make a new circle, it should be bigger than the previous one. Like it should be even large, I mean, concentric. It's called concentric. Do not attempt like this. These are not concentric. Concentric means that's the center one is the smallest, then it gets bigger, and the last one even gets larger, like that. So please make concentric circles. Do not make similar circles. Okay. So, and at least 3. So remember that. If you have done it right now, please give yourself full credit. Then the direction of current in the wire is reversed. The magnitude of current is unchanged. State the fact. If that is the case, then you should remember that the direction of field will reverse, but the circles will stay the same because the magnitude just changes the strength and direction changes, direction of current changes where the magnetic field is going to form. Now, this question, a student completes circuit measures current in 6 ohm resistor. Fine. On figure, draw an ammeter, symbol one gap and straight lines to indicate wires, and the other gap how the student should do this. What is this, by the way? I don't understand it at all. Student completes the circuit and measures current 6 in the 6 ohm. Okay, so to find current in 6 ohm, we must put an ammeter right here, because this is connected to the main wire, and main wire will give you the current. A voltmeter is connected to measure the potential difference across 4. So draw voltmeter connected to correct. Across 4, the voltmeter should always be parallel, never in series. Then with the circuit completed, the current is in 2 ampere is 2.5. So what is this, by the way? Draw an ammeter, symbol one gap and straight lines to indicate wires. So these should be the straight lines. Okay. All right. Now the circuit is complete. With the circuit completed, the current in 2 is 2.5. So the current here is 2.5 ampere. Now it says calculate the current in 6 ohm. So what you do? First of all, I will find what is the voltage across this one. Whatever the voltage is across this one, like this whole branch voltage will be the same as this whole branch voltage, by the way. So first of all, I would use V is equal to IR. The current is 2.5, resistance is 2. So that's 5 volts, which means if this whole branch gets 5 volts, this also gets 5 volts, which means 4 is also getting 5 volts. So I'm going to use V is equal to IR to find the current. So 5 divided by 4 is 1.25 amps. So this is 1.25 ampere, just like that, right? Okay, cool. Now, if you look at it, we need to find the current in this ampere. Now, if there was a current that was going from here, that must have been divided into this. So in parallel, the current is added. So we write I will be equal to 2.5 plus 1.25. This would give us like 3.75 ampere. So that should be our answer. All right. Anybody who could not understand, please let me know. This seems pretty easy, right? So the thing is, you should always remember in parallel, just run your finger. Just move your finger like you start from the positive side. You move your finger, the current will be same here. And the moment you want to decide whether you go this direction, it means that the same current is going to split. So if you add this and this together, you're going to get full current. It's pretty simple, right? Now, then says shows the same electrical circuit with alternating current as they have used, as you see. This is the symbol of alternating. Okay, and wire gap. On figure, draw a symbol in one gap and straight lines to indicate other gaps. So there is a current. So there is a current from right to left. So there is a current. He wants us to go from right to left. Okay. There's a current from in 4 ohm. The only way that could be possible if we attach a diode. And like this. If you attach a diode like this, it will only allow current to pass from here. It will not allow from the other direction. So it will go from right to left. And an alternating current, right? There's a current from right to left 4 resistor and alternating current into. So we have to just connect a wire. And that is it. Wow. Now let's go to the last one. This is, if you don't know, diode is a device that only lets current go through this place sign. It doesn't let current go through this side. It doesn't. Now, state the difference between nuclear fission, nuclear fusion. Now, what is fission? What is fusion? You just need to remember fission. Fission is a process where a large, or instead of writing large, write massive. Massive, unstable nucleus breaks into more stable, less massive nuclei. Nuclei means there could be 2 of them, or usually there are 2, but there could be other products as well. Now, infusion is a process where small, unstable nuclei combine to form a more stable nucleus. Now, radioactive tracers emitted gamma rays can be used in medicine. The half-life of source of gamma rays is 6 hours. Explain why the source of gamma rays used this way should not have half-life shorter or longer. Now, it's saying radioactive tracer. So, if you eat this medicine, so its half-life is 6 hours. So, the medicine should quickly, this gamma rays should quickly go out of your body, right? So if the substance remains in your body, it means it will harm you. And if it is too short, how will you check what is wrong with you, right? So for longer half-life, it is harmful. For radioactive substance to stay in your body, and for shorter half-life, insufficient time to diagnose the problem. So that's one. Now, it says technetium is a source of gamma rays often used as radioactive tracer produced by molybdenum. Okay, molybdenum. Okay, whatever. And emits beta. So it says complete this. So beta is 0, -1, and 99, 99, and 42, 43. Technetium is a radioactive nuclide. State and the use of radioactive nuclide in medicine. Whoa.
Sir, why 43?
Huh?
Why 43?
Because you make an equation 42 equals to x minus 1. Can't you do this?
Oh, okay, sir.
Now, curing of cancer is done through gamma rays. So that's one thing you should remember. Also, sterilization of medical equipment can be done. So that would be it. Any questions now?
No.